What's up, everyone? Today we're going to talk about right triangle trigonometry and its applications. All right, so looking at this triangle instead, just kind of picking it apart a little bit first, you'll notice that we've labeled the angles with capital letters. So you could either call this angle at bottom angle A, you could call it angle BAC, you could also call it angle theta. That's what this letter is. It's the Greek letter theta. Similarly, with this top right angle, you could call it angle B, you could call it angle ABC, or you can call it angle phi or phi. We'll hear it both ways. I usually say phi. You'll also notice that the sides are labeled with lowercase letters and they're kind of connected to its corresponding angle, to the angle opposite of it. So opposite of angle A is lowercase a, et cetera, et cetera. So just kind of give you the lay of the land there. But what we're going to do with this triangle is we're just going to list out the three trig ratios for both theta and for phi. All right, so I'm going to start by writing out all my information for theta. So focusing on theta, if I look at the sine of theta, remember sine is opposite over hypotenuse. So that means in terms of the lowercase letters for my sides, I would be looking at A over C. Cosine of theta, remember cosine is adjacent over hypotenuse. So adjacent is B over my hypotenuse of C. Finally, tangent of theta, tangent is opposite over adjacent, so that means A over B. Next, looking at phi. So when I start to focus on phi, note that the hypotenuse stays in the same place, right? The hypotenuse is always across from the right angle. But if I'm now focusing on angle phi or angle phi, the opposite side is now B and the adjacent side is now A. So it really does depend on which angle you're focusing on when you're labeling the opposite versus the opposite versus the adjacent. So if I'm looking at angle phi, that means my sine would be the opposite over the hypotenuse. So now it's B over C. Cosine would be adjacent over hypotenuse. So A over C. And tangent would be opposite over adjacent, or B over A. All right, so let's put some actual numbers to the sides. So in example 1, we're listing the three trig ratios for theta and for phi. So same kind of deal as the last side, except now we actually have numbers for our side lengths. At least we have numbers for 2 of our side lengths. And that's what I noticed first, is I don't have a hypotenuse. So if I remember all right triangles, I can use the Pythagorean theorem, which says a squared plus b squared equals c squared. Now a and b it doesn't matter which one you use. It's just that c has to be the hypotenuse. So that's the only placement that really matters, is that this is my hypotenuse, which is what I'm looking for. So that means I could sub in 3 for a and 2 for b, and use that to find C, my hypotenuse. So 9 plus 4 gets me 13. So after taking the square root, that means C equals the square root of 13. So note, this is the one time, or one of the few times, that you don't need the plus or minus with the square root. Since you're looking for the length of a triangle, it's going to be positive. So we're looking at that hypotenuse length being the square root of 13. So again, I'm going to write out my information that I'm looking for. So focusing on angle theta first, sine of theta, again, is the opposite over the hypotenuse. So 2 over the square root of 13. So it's been a while since you've seen radicals in the denominator, but it's still not okay to leave radicals in the denominator. So what we'll have to do is we're going to multiply numerator and denominator by that radical 13. So what that will leave us with is, in the numerator, 2 times root 13 is just 2 root 13. But in the denominator, root 13 times root 13 is just a plain old 13. It eliminates the radical for us. When I look at cosine of theta, I'm looking at the adjacent over the hypotenuse. So 3 over the square root of 13. And then I can either repeat the process or just kind of connect the dots to see, all right, well, I started with something similar and this is what I ended up with. So that means my answer will look similar. It's just that I'll have a 3 in place of that 2. Or you can go through the steps to rationalize the denominator again. And tangent of theta, tangent being opposite over hypotenuse, gives me 2/3. So focusing on phi now, I'm looking at opposite side being 3 now over the square root of 13. And I already know what that rationalizes to because I did it for theta. Cosine of phi being the adjacent over the hypotenuse, so 2 over the square root of 13. Again, I already know what that rationalizes to, 2 root 13 over 13. And finally, tangent of phi, opposite over adjacent, so 3 over 2.